in lieu of doing a CSS review or anything like this. This is going to occupy some of our time. So this is where you get introduced to the programming language called Ruby, which is a lovely language. We're going to talk, and again, this is a whirlwind tour here. Don't expect to master Ruby today, and you know what? Expect even to be a little bit frustrated and overwhelmed because you can't learn it all in an hour. We can give you some very high-level overview of it. We can kind of get you functional in it, and just enough to be able to like follow along with the assignments and to be able to develop within the Sinatra framework, which is also a Ruby program. So, talk about Ruby. We'll talk about objects. Ruby is what we call an object-oriented programming language. So if you think of objects in the real world, this is very much true in the Ruby world as well. We can define objects to have any characteristics and traits we want. And each of these objects has actions that you can perform upon it called methods. We'll talk about some very introductory concepts here concerning variables. These are values that you set in memory for later retrieval. We'll talk about string interpolation. Sounds very fancy, but basically it just means you're taking a string of characters, it could be hello world, and sticking the value of a variable within that string. So very, very important, especially when you're talking about Sinatra, because it's very text heavy. I mean, we're making stuff for content for people to consume. And of course, you know, given the nature of the media, that's usually text. Well, not usually, but oftentimes is text. We'll talk about how to get our program to execute certain pieces of code. This is the control flow. Some parts we want to execute given certain conditions. Some parts we want to skip over given other conditions. Other parts we want to repeat over and over and over again, or however many times we decide. That's all part of control flow. We'll talk about methods. Now, this was a part of this object-oriented programming concept. We create a class that sort of defines an abstract concept in the language. And we define these actions that you can perform upon an instance of that class. So don't get overwhelmed. We're going to make this as simple as possible. I know these are maybe not language that you're used to, but I'll try to make it as easy to digest as possible. Then we'll talk about a different kind of data structure. So we have these variables, and then we're going to talk about hashes and arrays. These are ways to structure different variables or to structure different data. Okay, so, well, here's a question. What is a programming language? You saw it? Boom, there it is. What's a programming language? Anyone tell me? Well, there's two more people. For those who just arrived, we're going to engage you in this class right away. Question on before you is, what is a programming language? No one wants to help me out here?
It's a language that helps you connect with the computer.
That's kind of, yeah, you know. So here's the Wikipedia definition. It says a programming language is a formal constructed language designed to communicate instructions to a machine, particularly a computer. Doesn't really mean much, right? It doesn't even really mean much to me. That's just what Wikipedia says about what a programming language is and what the intended purpose behind it. So we say, what does that all mean? We're going to tell the computer how to do things, right? This is a set of repeatable instructions that gets loaded into memory and it gets fed through the CPU, which turns on all the switches on and off, and it does all those amazing things that we now take for granted here in the 21st century. Whoops. So the Ruby language in particular, now Ruby is just one of probably 1,000. I don't know. I've never actually looked up how many languages there are. I would be surprised if there wasn't at least 1,000. And there's new ones all the time. So Ruby was created by a Japanese computer scientist named Yukihiro Matsumoto, and his nickname is Matt. So Ruby's been around with us, since 1995. So what is that, 21 years now? For whatever reason, all of a sudden Ruby became popular when creating web applications. So far you guys have been creating web pages more than anything, because you haven't been introduced to this this type of programming. You've seen HTML, you've seen CSS, but you haven't done any JavaScript. JavaScript being another language. I suspect Ruby on Rails had a lot to do with its current popularity, which was, I think, around 2007. So, mature language, certainly, 21 years old, and designed with programmer happiness in mind. Now, Matsumoto, I mean, you just got to love this guy. Like, I look at him and it just makes me happy. And like that's this kind of guy, right? He's an interesting, positive individual, and he loves things to be beautiful, right? He likes beautiful code. Now, does that mean clever solutions to problems, or does it mean the visual appearance? I think he means the visual appearance in Matsumoto's case. But if you ever meet him, you can ask him for yourself. So now we're getting right down to Ruby. Ruby, the object-oriented language. Basically everything. Everything that you're working with in Ruby is an object. Certain languages, these are called primitive types, strings, integers, float values, and booleans. In Ruby, these all come down to an object class. Now, this isn't super important to you guys, but it does kind of set Ruby apart in some ways, because not all languages are like that. All languages do, however, have strings. They have integers. So if you remember from math class, an integer is simply a number that doesn't have a decimal point or some fractional value. It starts at negative infinity, goes up to 0, and goes off into positive infinity. Floats, on the other hand, are these fractional values. Floats are interesting in computers. I'll show you why in just a little while. Because, well, we'll get to that. Then we're talking about booleans. Now, probably most of you are kind of familiar with this vague concept of the bit. Bit is truncated binary digit. And a binary meaning 2, basically. It can either be 0 or 1, or on or off. The way we represent it in Ruby and most other languages as well is we call it true or false, because I think it's a little bit more meaningful to people. So true, the light switch is on. False, the light switch is off. Also an object. So now we're talking about variables. Now this is where I'm going to break out of the slides, and you guys can follow along. And we're going to go real slow, and we're just going to show you a few things about Ruby and how you the various ways that you can interact with it. So if you haven't already, go to Cloud9, create a new workspace. This should all be a review. So I'm going to call this week 2, day 2 demo. Demoing. We'll call it Ruby throwaway demo session, because I'll probably delete it after. I'm not even actually going to save anything, and this is just for you guys to get an idea. It doesn't really matter which one you pick, because they all have Ruby installed, and in fact, especially those of you who have Macintoshes, probably have Ruby on the command line. You don't even need Cloud9 if you don't want to. You can execute this the same way that you do in Cloud9. So I do that, create the workspace. I should have done that, shouldn't have delayed, because this will take, a good 15, 20 seconds. So As this is firing up, we're getting to this this demonstration of variables. Now, there's a couple of ways we can interact with Ruby. The first way, not necessarily the primary way, but there's a very handy command line tool here called IRB. Now, when you're in the Ruby world, RB, of course, it signifies that this has something to do with Ruby. You'll see this all over the place if you investigate Ruby to any degree. So the I in IRB means interactive Ruby. And what this does, this is called a REPL, REPL. What does that stand for? Read, evaluate, print, loop. Is that right, Nick? Read, evaluate, print, loop. I think so too. No one really says REPL, right? But this is what we're talking about, a REPL. So it reads a command. It could be anything. I'm going to make a string because this is kind of, the traditional first program. Hello world. It reads it. I hit enter. It evaluates it. It prints the results, and then it loops back around and it waits for another instruction. Read, evaluate, print, loop. So what did I do? Nothing, really. This is a certain type of data. It's called a string. A string is delimited by either single quotes or double quotes. So anything I put between here is a string. Anything I put between double quotes, look at this. It's hard to type standing up, is also a string, just like that. This doesn't do me really any good, though. I mean, I'm kind of making these declarations. I hit enter. It evaluates the statement that I made, and it prints it out. And then it's lost to time, right? It's just gone. So we're talking about variables. Variables allow you to store this data and keep it for later. So we've already seen strings. Let's try an integer. We'll call it x. And we'll say x equals 1. So reads it. Just given the inner workings of Ruby, it takes this x symbol, it puts a special spot for it in memory, and it stores that value there. So now anytime I come back and I enter x on this interactive Ruby command line, it's going to retrieve the value, right? And let's do another thing. We'll say greeting. Hello, class. So whereas before, I was just printing these things to the screen, when I use this equal sign, and this is always the way it operates, you have the variable, you have the equal sign, and then you have the value that you want to assign to that variable. I press enter, and it prints that thing, and now anytime I want to see what's inside greeting, I just type it in. And it sits there until IRB is terminated, and maybe the operating system does some internal garbage collection, or it just gets overwritten by something else. But as long as IRB is executing, or as long as my Ruby program, in whatever form it takes, is executing, this variable for the moment is going to persist in memory. It's going to be there, and it's going to be something that we can access. So the nice thing about a REPL here, or this Ruby, interactive Ruby, is that you can also perform, just mathematical operations. I know this is a big part of programming. And now we're not talking about like discrete mathematics or trigonometry. We're just talking basically about arithmetic. Of course, you can do these things, but a big part of getting your program to do what it wants is being a master of arithmetic, because that's what it all comes down to, right? Even multiplication is just repeated addition, and division is just repeated subtraction. You add numbers, you subtract numbers, you do it in some form, you get these results. And your program does remarkable things, really. So I have 1 plus 4 equals 5. Let's say 5 times 5. You might not be familiar with that symbol there. That's the asterisk. That multiplies. So 5 times 5 is 25, of course. You might have expected something like this. I don't know. You might have expected 5x5. That doesn't make any sense to Ruby. Watch what happens when I execute it. Syntax error. Unexpected identifier. It doesn't know what that means. So if I want to multiply numbers, I use the asterisk or the star. So another obvious one, of course, would be to subtract. Let's say 10. Let's say 10 minus 2. These are very just, small numbers. And division. So this is like the different one, right? So multiplication, we don't have one of those little lines with the 2 dots above it on our keyboard. So we use a / like that. 10 divided by 2. Now here's a question. Should be easy to answer. What if I want to divide a number and save it for later? How do I do that? Assign it a variable. Exactly. Perfect. So, and when it comes to naming variables, this is also something that's very important. It's important in the same way that indenting your HTML is important. And it's important in the same way as indenting your CSS. Give it a descriptive name, something that will tell you what is contained in this variable. Now, we're using like 2 different numbers here. This is kind of weird, but a good name would be, say, results, right? So this is a very simple explanation, or sorry, a simple demonstration. But if I do 10 divided by 2 like this, results now contains that value. So now how do you think I would take this result and multiply it and assign it to another variable? What would that look like? I'm going to put my fingers above the keys. How would I do that? I want to multiply the value contained in results and assign it to a different variable.
You have to have a name for the variable.
Okay, so we'll call it, not exactly a good descriptive name, but we'll call it new result, or new results. We say =, results times, and we can put any number in that. So right now we know that results is currently equal to 5. Let's say we multiply it by 8. Now, new results contains this value 40. Right. That's your very basic introduction to variables. Now, we've had a couple of other ones. So we've already assigned a greeting variable. That's a string type. What do you think would happen if I said greeting plus new result? Something weird going to happen?
40 at the end of it.
You think so? Let's find out. So I'm trying to add a string and an integer, a value without any fraction. Uh-oh. Undefined. Oh, wait, sorry. Did anyone see the error I made?
Type in the S.
Yeah. Very picky, right?
Yeah.
It's got to be precise, just like you guys have already experienced with HTML. No room for errors when you're doing this kind of stuff. Still, it's telling me, okay, well, no implicit conversion of fixed num into string. Basically, it's just saying, well, this is a string, dummy. This is an integer. You can't add these two together like they're integers, right? That doesn't make any sense to Ruby. Some languages will let you do something very similar to this, but not in Ruby. JavaScript will let you use that + sign operator, and it will just treat both of them like they're a string. We could do this. We could convert new results to a string. Here's your introduction to a method. Remember, everything's an object, and every object has methods. So I have an instance of a fixed num, or an integer, as well, that's what I like to call it, certainly. It has this little w2s method. I can perform this action, and I can call this method on the integer object and convert it to a string. Does it work? There it is. Hello class, and then it's got no space and then a 40. When we get to string interpolation, there will be a much better demonstration there. Okay, so we've done strings, we've done integers. Let's do floats. So a float is any value with a decimal. Now I'm going to show you something weird about floats. I'm going to add 0.5 to 0.5, and I get 1.0, right? So 1.0 is actually an integer, right? But no, it's not. Not to Ruby. It's a float.
Because there's a decimal zero.
Because there's a decimal zero, exactly. These are two totally different data types. And in fact, I could say 1.0, does this equal 1? Oh, it does. True. Okay. Never mind. That's something different. Okay. But yeah, demo went bad. Let me show you something weird about floats. Now, I type in 0.1. In fact, let's assign this to a variable just to get you used to that idea. We'll say x equals 0.1. We'll say y equals 0.2. What happens when I say x plus y? What value am I going to get? 0.3? That's kind of weird. You guys all see that? The question I ask you is how many numbers are there between 0.1 and 0.2? Or, if it makes it easier, how many numbers are there between 0 and 1? 99. There's more than that. You can have it infinitesimally small. It never ends, right? But our computer ends. We have to have some way to store these kind of numbers. What you're seeing here is just the side effect of how we store floats. These are not infinite values, but we have to have this handled some way. I don't know specifically why it handles this way, but if you are very interested, I believe floats are defined as an IEEE standard. So this is something that you can go and investigate for yourself. Most languages will do the exact same thing. In fact, let me just show you. I think we might even have a Python interpreter. Yeah. So if I do 0.1 plus 0.2, it might not be exactly the same, but let's try it. No, it is. It's exactly the same. Surprise. Right? They probably adhere to that same standard of representing floats in memory. Something to be aware of. So if you ever write a program, I don't know, in finance or something, you know, you're a stock trader or something, you might have some rounding errors. Who knows? Be indicted for fraud because of these rounding errors.
So what is the function to round?
Sorry?
What is the function to round? Like, let's say you want to round 0.1.
Oh. Okay. IRB. There is a ceiling function. Is that right, Nick? I'm not exactly sure either. Here's where we turn to Google. Let's say Ruby round decimal. Sure. How do you round a float to 2 decimal places? Well, this is JRuby, but you know it's going to be close enough. We've got to make this a little bit bigger. Well, that's the question, right? So now Stack Overflow is a wonderful resource, and I'm not sure if you guys have seen this yet, but it always starts with somebody who doesn't know how to do something. And this guy says, well, how do you round a float to a couple of decimal places in JRuby? That's the question. Here's the answers, and basically anyone can come along and answer. So, well, this seems pretty reasonable. And notice that there's an accepted answer. So the check mark here means that this person saw this one first and it answered his question. But anyone can come along here and upvote. this was helpful to me. So, okay, now this guy gets a little bit of a few points. So here's my profile. I got 1,621 points. Sounds like a lot, but then you look at this guy. Well, he's got 45,000 points, and so okay, I guess I got a long way to go. But let's try it out over here. So I can paste that in. Having consulted Stack Overflow now, I know how to round to a certain number of decimal places, right? This, anytime you see a period here, that means this is a method call, right? All the numbers. We're going to talk about methods in just a little while. So nice and slow. Are we going, you guys are, this is too easy for you? Okay. We got one more data type, the Boolean. We say x equals true, y equals false. Does x equal y? False. Just yes or no, one or the other. Again, a very important data type because there's going to come a time when you want to test these conditions. If this expression is true, then execute this code. If it's false, do something different. Or if some other condition is true. This is the control flow that we're going to get to eventually. Okay, so your introduction to variables. Now we have basically what we just did right now. We assigned Yukihiro Matsumoto, the famous Mats. I don't think he's 35, but let's say that is his age. He's got 2.5 siblings. And is he rich? False. So yes or no question. Yes or no, true or false. And whoever made these slides, well, you know, he's probably doing all right. I've never met him. I hope to meet him one day. All right. So I've already addressed this. Naming is very important. Here's a couple of bad ones. I sort of used the bad examples. I said x equals y. So unless you're using something like, you know, the Pythagorean theorem, it might not be appropriate to call your variables a squared plus b squared equals c squared or something like that, right? There's a time and a place, but you got to do something that makes sense in the context of what you're writing. Some good ones. If you're working with like maybe a blog article or something, you have a title, the time it was published. You can tell exactly what these variables are supposed to contain just by how the author described them. So the author, whoever that person is, gave very descriptive names, and they tell it right. We can tell right away just by looking at them what these variables, what kind of data they contain. So here's some bad ones. You see this from now. You know, having taught introductory computer programming for many, many years at the University of Calgary, I would always see like first-time programmers saying like A1, A2, A3. These are terrible variable names. They don't even make any sense. So I don't know if in my case I've kind of set a bad example, but these aren't descriptive. I can't tell what's in stuff. It could be anything. Or a counter, that's not so bad, actually. I mean, it's going to be an integer, probably. You know, it's going to count up by 1 every time something happens. Not a terrible one. But output, response, yeah. Okay, so now this is where we get to string interpolation. And I'm going to take a step back. We're going to do something a little bit different than interactive Ruby, which is what I just showed you a moment ago. Interactive Ruby is great if you want to do something, test something out, make sure something like, say, maybe a class you load doesn't crash. But eventually, you're going to feel the limits of it, and you're going to want to write your program into a file and execute the file instead of typing out the commands one at a time. So I use that Hello World template. I'm just going to clean these things up to avoid confusion. Get rid of all these things. Delete. Yes to all. Okay. I'm going to make a new one. So I'm going to do the traditional Hello World program. And you are welcome to follow along. So I'm going to call it Hello. Whoops. Hello. Hello.rb. RB, of course, means Ruby. And when you're writing a Ruby program, put an RB as the file extension. Press enter, open it up. And this is well, it's not the simplest program you can write, but it's pretty darn simple. All I'm going to do is print out hello world. If I can get my computer to work. There we go. Put S hello world. So if you have any sort of programming experience, you're drawing something from, I don't know, high school or university or whatever, you've probably seen a print statement. Puts is the Ruby version of that, and I think the S stands for string. So put string. Put this to standard output. So here's my very first program. I type save, and then I come back down to the bash command line. I'll give myself a little bit of room. So now to execute this, all I have to do is invoke the Ruby interpreter. I type in Ruby on the command line, put a space, and then type in the name of my program. So Ruby space hello.rb. I press enter, hello world, just like that. Very first computer program. So far it doesn't seem like to have that much of an advantage over what we were doing before. But I think that advantage will reveal itself as we go along. So let's just try a couple things out. And we're demonstrating string interpolation. So you've already seen me do, yes, question.
My bash is already set to IRB. How do I get it out of IRB?
Oh yes, very good question. So some of you might be looking at this. Sorry, there's certain things I just take for granted. And thank you for that question because it's not obvious. The fast way to get out of this is to hold Control D on your keyboard. Or sorry, hold Control and then press D, just like that. Be careful with that one because it will close the terminal too. That's just kind of the catch-all Linux way of shutting down a login session or certain programs. The other way, if you like to type, is just type in exit. Personally, I prefer the Control D method myself. Okay, so we're doing string interpolation. You already saw me do this. I did a weird little example where I assigned X a value. I think it was 40 or something like that. And then I did one of these. I said, print out X and convert X to a string. Not really a good way to do it. So there's a notification there. Some student in Vancouver needs help. Sorry, I cannot help you. All right, now this time I execute again. I type in Ruby hello, press enter, and then I got that weird 40 sitting on it. This is not really the way you're going to do this, right? You want to do something a little bit better. And I'm going to set that example by first setting a descriptive variable name. So this is going to be my name, DAN. And when you're working with strings, remember, it has to be within quotations. The quotations can be single or double, but they have to open and close with the matching one. And there's a couple more rules in there as well, but we'll cross that bridge when we get to it. So now instead of saying hello world, I want to give myself a friendly greeting. I take this out, and this is where the interpolation comes in. I'm not sure why they give it such a fancy name. I'm not sure what I would call it instead. But it always starts with a hashtag, a curly bracket, and it closes with a curly bracket. Now, anything you put between those two brackets is just ordinary Ruby code, right? I say type in name. So what this is going to do, one step after the other, first thing that Ruby does when I invoke the interpreter is it takes this spot in memory that I've labeled name, and it sticks the string, this 3-character string, DAN, inside that spot in memory. Then it comes down to here, and it says, oh, this is an empty space, I can ignore it. Then it comes to here, and it says, oh, look, there's some weird string interpolation here. I'm going to evaluate this expression, find out the value, and then glue it inside of the string. It's like copying and pasting something inside this string. So make sure it's saved. Come down here. I type in Ruby hello. Hello, Dan. There you go. And see, what's the difference, right? If I didn't have this hashtag curly brace mechanism here, how do I get the value out of name? That's all we're doing. We're taking the value that's been stored there, or maybe we're making a method call or something like that, and we're getting a value that we intend to print to screen. And when it comes time, this is something that's going to be printed to the web browser when you make your web pages with Sinatra. So without that interpolation, name isn't a variable. It just says, hello, name. Well, that's not what I wanted. I want to give myself a friendly greeting. So what that is just, it's called a string literal. It is exactly as it appears. I want to reference that value, retrieve it out of memory, and paste it into my string. I use that pound sign or hashtag curly brace operator. Hello, Dan. There we go. Now, nice thing about variables is that we can do anything. So, I don't know, I could say, hello, Jeet. Is that how I spell your name? Is it or no?
Yeah, that's good.
That is good. All right, hello, Jeet. There we go. All right. So, string interpolation. Any questions about that? We're about on slide 6, I think. We got 15. 9 more slides to go to your introduction to Ruby.
My bash isn't, well, my Cloud9 isn't letting me save the file, so every time I go to update it, it doesn't allow me to change my bash.
That's kind of weird.
Yeah.
I'm not sure why it's not letting you save.
I don't know.
Hmm.
I understand it in theory, and I'm sure I would get it in practice if it let me.
That's the funny thing about these things. It's real easy to come and watch me do this. But then, you're going to ask me for help, and I'm going to say, well, why don't you just assign this string to a variable? And you're going to be like, what the heck is he talking about? Well, you just saw me doing it for like half an hour. All right. That's the funny thing about programming. And that happens to me as well. I learn a new concept, and it's not until you actually sit down and put it into practice that this begins to make sense. So they use a slightly more complicated example, but it just goes to show you can use as many of these string interpolators as you want. And in this case, we got Matt's, we got his age, which is an integer. Interestingly, we don't have to call toString, right? Before we use that plus sign, we're trying to do this. The interpolator converts it to a string, whatever it may be. It's going to try to print it to something that's readable on the screen. Okay, so now this is where we get to controlling flow. Basically, well, here, yeah, the pseudocode is excellent here. If something is true, do this. Otherwise, do something different. Everything that follows an if statement is going to evaluate to either true or false, right? And we can do all sorts of different tests. We could say, is X bigger than Y? Is Matsumoto is rich equal to Dan is rich? It'd probably be true because we're both poor. And otherwise, do something different here. So let's find, let's do a very simple example. Okay, whoops. Let's rejig our program just a little bit, if I can get to the right screen here. Whoops, go back. Controlling flow. Here we go. So I'm going to leave this up. I got my hello program. There's nothing stopping me from going and making another program. So let's make a new one. We'll say new file, and we'll call it planets. So this is a simple example. I hope means something to you. I cooked up earlier on. So once upon a time, okay, well, here, I'll pose the question to the class. Num planets. How many planets are there in our solar system? Is there? All right, okay, we're going to put 9. We're going to put 9. So I say if num planets equals 9, what's the difference between Well, notice the difference. I'm not going to ask you what the difference is, but look how I use equals here. I got two equal signs. This one assigns a value, one equal sign, takes the value on the right-hand side and assigns it to the left-hand side. That's an assignment operator. This one is a comparison operator. It's asking me, are the values I have presented here, are they equal? Are they the same? So if num planets equals 9, then I say puts, I guess Pluto is still a planet, like that. So when you open up one of these things, there's always a closing. What's the word here? Shoot. I've got a statement here. An if requires an end. I've created an if block, and at some point I have to tell Ruby that this if block has come to a close. It ends, right? So be careful. This is kind of like when you do your HTML tags, and you create the opening tag. Say maybe it's a P tag, and then my advice to you is to create the closing P tag right away. So if you're making an if statement like this, make sure you got the ends. Because if you don't, watch what happens. Well, actually, we'll run it like this first of all. And I'll show you what happens if you forget the end. So I say Ruby planets. Okay, so we've set the number of planets equal to 9. Starting right up at the top, so there's this value 9 at some place in memory. It's some weird hexadecimal address. Doesn't really matter where it is. Ruby knows where it is. And then I call it down here, and I ask, okay, well, is num planets equal to 9? Then, okay, well, that is true. So I step down here, and I execute the code because that is true. So what if it's false? Oh, wait, sure. I want to show you what happens if I forget the end. And I guarantee you're going to see syntax errors like this. This is what's called a syntax error. It's like missing a comma or a period. Unexpected end of input. The expecting keyword end. So Ruby is smart enough to know that something's amiss. It got to this point, executed this, made the comparison. It got to here, and it was like, oh, wait a minute. I don't know where to stop. All right. Crash. Program doesn't execute. Prematurely halts. Halts execution. End. All right. Problem solved. Come back here. Syntax error averted, I guess. Right? So now every time you do this, there's nothing to stop you from making another if statement in here. We could say if true, doesn't matter what it is. And we can nest these things. But every single time you do, for your own sanity, make sure you tab, just like when you're nesting HTML tags, and go slow. Remember, this is like you got to do a little bit, kind of build your outwards and go inwards, and just every single step, just make sure that everything's working the way you expect it to. And make sure you understand what it's doing. Otherwise, you're just going to get in over your head, and you're going to call me or Nick, and it's going to be like, whoa, I don't know what to do. And we're not going to know what to do either because your code's a mess. So make sure that you close these things off. Okay, so let's expand upon this. So we have this if statement in our own code. We can execute alternative code if num planets does not equal 9, right? So in the case that num planets is something different, I could say Pluto has been demoted or something. I don't know. I don't even know. I think people still say it's a planet. I'm not sure. This is just it got re-promoted?
Yeah.
Okay, so it got restored to its original status as a planet. Wonderful.
The size of Russia.
All right. So at this point, watch what happens. It's going to do the test just like it did before. and it's going to execute just like it did before, right? Num planets equals 9. This test is true. So this is control flow. This code gets executed, and then it stops. It skips over the rest. Nothing gets printed out, right? Because the else is false. Look at this. In plain English, if something is true, do this, else, or otherwise, do this instead. Do that. So if we want to change this, I say, okay, well, there are now 8 planets in our solar system. So I guess this dates back to 2009. I say Ruby planets. Well, Pluto has been demoted. So else is the catch-all. Now I want to stress this now. You only get one else in the if-else block. You only call that once. You can't do this. Whoops, come back up here. This is the catch-all. If every other preceding condition is false, this will get executed, but you can only have one. This one doesn't make any sense. If I do this, and look, it's already telling me something's wrong, syntax error. I'm expecting this thing to end. You can't have 2 else's in an if-else block. This doesn't make sense to Ruby. So I'm not even going to bother executing it. It's Cloud9 sort of executed it in advance and said, this doesn't work. So let's get rid of that. Problem solved. Error disappears. We still got a problem, and this is kind of a logical problem. Did anyone spot it? This is a different kind of bug. Our program executes to completion without crashing, but there's still a bug in this program. Okay, what if num planets equals 7? So it's, again, it works. Pluto has been demoted, but what other planet was demoted? Right? That doesn't make any sense.
It's just referencing Pluto.
Yeah, exactly. But we need another condition. We need to say, well, okay, well, we know that there's either 8 or 9 planets in our solar system, depending on who you ask. We've got to insert something in the middle and make that test. So if it's 7, this makes more sense. Where are you? I don't know. I don't know what solar system I'm in. 7, where are you? Well, it's not our solar system. That doesn't make any sense. So what I can do inside here is I can make another test, and I can say, well, if there's 8 planets, then it must be it's debatable. I guess maybe this is still a matter of debate. We use what's called an else if, and it's stuck together. So if any of you have any sort of programming background, you're probably familiar with it looking like this, and most languages do. Now, Ruby's a little bit exceptional in that, I guess. I think it's been a while since I've done Python, but I think Python does it this way. Elif, right? In Ruby, it's else if. So if the first condition doesn't hold true, but maybe this one does. Else if planets equals 8. Pluto is no longer a planet. So let's try this out. Num planets, right now it's 7. We have no idea what solar system we're in. Let's do the first test. Whoops. Set it to 9. Come on. There we go. 9. I guess Pluto's still a planet. Okay, one more test. 8. One of these conditions is going to hold true just by the nature of the if-else block. If the first condition isn't true and the second condition isn't true, then the else one will be true. The else is optional. The else if is optional. You define these as needed depending on what you're trying to accomplish. This also works in the case that you live in some solar system with, like, I don't know, 1,000, 10,000 planets. Where are you? I have no idea. Or how about -1 planets? This is like some sort of weird alternate antimatter solar system that has -1 planets in it. Still don't know where I am. 3 conditions that can be evaluated to true. Test the first one, then it executes this code. If this condition is true, the rest is irrelevant. It just skips over the else if. It doesn't even look at it. Skips over the else, and it continues on executing. And it's the same thing. If this one is false, then it moves on to the next else if, and it tests that. So what I've done here is I built it up slowly just to show you that none of these things, well, except for the if, none of these are required. If you're going to do one of these control flow things, at the very least, you need an if. The else is optional. The else if is optional. And you can have as many else ifs as you want. That's weird. All right. You can have as many as these once. We could go count them right down to 0. We could do whatever. So yeah, well, just to show you that it works, I'll set that to 7. And then while you're watching this execute, are there any questions? Right? Seems easy. It's easy when I'm doing it. Right? You guys are going to have to do this eventually as well. So I guess the big points to remember are that the else's are optional. You can have any number of else ifs, including 0. And basically anything after this if or these else if keywords will evaluate to a Boolean expression. It's either going to be true or false, yes or no, 1 or 0. Okay, moving forward. Okay, so methods. Yes. Now, what's a good way to introduce you to methods? Now, I did these works, and now I'm starting to have doubts about what I was going to do. So you've seen some methods in action, maybe without even realizing it. Now, and I mean, I told you this one. Recall, I'm going to drop down to the IRB interpreter again. Recall that everything in Ruby is an object. And we're talking about object-oriented programming. So I can say, hello world. That's an object. And each of these things has methods. Now there is a method I can call on this object to make it all uppercase. I can't remember what it is. I think it's just upcase. There it is, yeah. So it took every single letter in the string and converted it to its corresponding capital letter. Hopefully you can see that. This upcase is a method. Same as, let's say we have x equals 1. We'll say y equals 1. And we say put x to string plus, so this is a very convoluted example, plus y to string plus equal sign plus y plus x, or sorry, x plus y to string. So I've made 3 method calls. Let's see if this actually works. Oop, nope. Oh, I missed a plus sign. Hang on. Right there. See, this always happens. This is why you go slow. 1 plus 1 equals 2. A lot of stuff happening here. I made a method call on the x fixed num object. 2s is that method. Performed an action. I took the integer one, made it into the character one, the string one. Then I added that to a string containing a plus sign. Then I added that, whoops, that was the faulty one. I added that to another integer that's been converted to a string. Then I added that to a string containing an equal sign. And then I added those two numbers for real, x plus 1, converted it to the results to a string, and then spat it out to the screen. That's the kind of stuff you do, right? So if you want to, like, I don't know, write a basic application to teach children arithmetic, that's what it would kind of look like. You could also use string interpolation. Okay, so I'm wondering if maybe this would be good for a demonstration later. Let's come back to this. And when I mean later, I mean maybe next day we'll do this as part of the review. Because we're talking, you guys have been introduced to some fundamental programming concepts. I don't want to give you too much, is what it comes down to. And this is a very good opportunity for review demonstrations on Monday. So let's put this on the back burner just for now. I guess we can't avoid doing these functions, though. All right. So we see a bunch of different elements. And what I'm going to do is I'm just going to copy and paste these. Oh, shoot. Okay, we can't escape this. Let's make another program. And then we'll kind of shut this down. And you guys can start working through the details in your coursework. So we'll call this new file, we'll say hello 2.0.rb. So this is a brand new hello program. So before, I had a very simple program that calls hello world. Easy. Want to make sure it runs. Ruby hello 2.0. Hello world. Okay, so now when you're making methods, you're taking code, you're putting it into memory, and then you're giving yourself the option to call it again and again and again. We could just keep calling put s like this as many times as we want. And really, when it comes down to it, this isn't going to save you that much time, but I got to show you what I mean when I say I create repeatable code. So it does this, creates hello world a whole bunch of different times, one after the other. So what I want to do instead is take all this and wrap it inside of a method call. And I'm going to use this method call, and I'm going to pass a value to that method, and whatever name I pass to that method is going to give that person a friendly greeting. So when defining a method, you use def. Def, define, definition, whatever you want to call it. And then you give your method a name. Now this is just like with variables. Give it something descriptive. Friendly greeting. And when we're doing Ruby, where we would normally put spaces in the word, we put an underscore. Some languages like to do this. This is what Ruby does. This is called snake casing. This is called camel casing. When you switch over to JavaScript, I think that's probably the more common style. But with Ruby, it's always this snake casing. The camel being, up and it looks like a hump. The snake, I guess, just because it's kind of flat and it stays close to the ground. So we do this. Not really saving ourselves any work, but we can get the same results. So I've defined the function. I call the program. What do you think is going to happen? Let's try it. Something happened, but nothing got printed to the screen. Any guesses as to how I get this thing to print to the screen? All right. Now, this, especially for beginners, this is a concept that doesn't come naturally. I mean, it doesn't come naturally for anyone. This is just something that you come to learn. What I have done here, this program did do something, but it doesn't look like it. I execute Ruby, starts at the top, blank line, sees this def, and it says, okay, well, I know def means that this is going to be a function definition. I'm going to set aside a slice of memory, and then I'm going to put all that code and do whatever the magic of the interpreter does and translate all this into ones and zeros. Keep putting that into memory until I get to the end. And it just sits there. It sits there and waits until someone actually calls the method. So I've got to call the method. And I do that by simply printing the method name. Okay, so now watch the difference. Before I didn't have anything printed to the screen. Now it says hello world. Right? This piece of code is now accessible, and I can call it as many times as I want anywhere else in the program. So let's do that again. Let's make a few of them. Just like that. Okay? So it prints out hello world 5 times to the screen. Didn't really save ourselves any time doing it the old way, but this is what you do when you define a method. Now, Ruby has a philosophy. It's not unique to Ruby by any means, but it's called DRY. D-R-Y. Don't repeat yourself. If you find yourself copying and pasting code, it's time to define a method. So I'm going to make this a little bit better, though. When you're working with methods, you can pass what are called parameters. So now maybe I just want to give a whole bunch of different friendly greetings, pass it a unique name for the people that I know, and have it print out a unique greeting every single time. So I want to say, hello, Chris, hello, Dan, hello, Jeet, and for everyone in the class. So I can define what's called a parameter. On the function definition, I use brackets, and I give that parameter a name. This becomes a variable. This takes on the value that was passed, and that value can be accessed within the method call. And then it disappears once the method has finished executing. So I'm going to take that name, and I'm going to interpolate it into the string, like that. And as expected, when the name is passed or a name is provided, that person will receive a greeting. Right now, it's not going to work, though. I'm going to show you. I execute the code. It gives me actually a pretty helpful error message. Wrong number of arguments. Arguments mean the same thing as parameters. It's not arguing with you. It's just saying, I was expecting some value to be assigned to name, and you didn't give me one. So what I need to do is provide it one. So I say, okay, hello, Chris. I press enter. There we go. Hello, Chris. Now you're starting to see the power of the method or the function, whichever one you want to call it. We talk about methods in Ruby. Hello, Dan. Not me, but Dan sitting next to Chris. Hello, Chris. Hello, Dan. No need to repeat the code. No need to call put S. Hello. Whoops. What on earth? Let me out of here. Yeah, jeez. All right. Hello. G. There we go. Over and over and over again. I can do this all day, right? So this is this is why we define methods, so that we can reuse the code in a way that we determine. Any questions about that? This is a very fair point on which to have questions. And I do expect you to kind of be like, well, what the heck is going on here? That's okay. You've been given a lot of information. And if you've never seen any of this before, yeah, it looks real easy when I'm doing it. It's going to be really difficult when you sit down and you're even looking at it on the screen. Very different thing to be seeing me do it and to actually put it into practice. But that's what you came here for. So let's wrap this up. We've got a few more slides to go. This is actually a very useful method. If you can see, we've actually kind of used everything we've learned up until this point. So we have humanized time measured in minutes. We know that because we've been given a very descriptive argument or parameter, whichever terminology you prefer. So down here, I call this function, I pass it this value, and then Ruby jumps all the way back up to here, assigns 120 to this variable or this argument minutes. And then it asks, okay, well, if minutes is greater than or equal to 60, then we interpolate a string. We say this was, well, in this case, it'll be 120 divided by 60 equals 2. 2 hours ago, comes down here and assigns it to that variable. Notice we did something a little bit different. I can do the same thing in my program. Actually, that's a good point to bring up. This isn't exactly the best way to do it. Put S. That's kind of an amateur mistake. Problem is now, it's not going to print anything. So where is this going? It's actually being returned to the context in which it was called. So, hello, Chris. I can assign it these variables. Now, this is getting to the point where, okay, well, this is just ridiculous. This is obviously just a demonstration. But what I'm doing is taking the results of having called that method and assigning it to a variable. Like that. Still not printing out. I have to take the values that have been assigned and print them to the screen. So, hello, Chris. Hello, Dan. Doesn't look easier, but this is the way you do it. And it does look easier when you're getting to something a little bit more complex. There we go. So now we're kind of back to where we started, right? Everybody see what's happening there? I hope. Okay. All right. Now, I just remembered what's coming up on the next slides. And I'm kind of dreading it because you guys have already had so much. So here we return this response. Now with Ruby, the last line to be executed is the line that gets returned to the calling context. And you see that here. The last line to be called in friendly greeting is also the first line. First line, last line. This value is called here, goes up to here, interpolates this string, and that string gets assigned to the value, hello, Chris. Same thing, comes back. Friendly greeting, Dan, bam. This value is the last line executed, gets returned to here, gets assigned to this variable, and so forth. And these variables now contain the values which I can put to the screen. So that's the lesson to be learned there. And next, oh no, combining our data. Oh. So now we're talking about hashes and arrays. Does anyone know what an array is? You must know at least from like university math or high school math. What's an array?
In arrays, you can put the values like range from 1 to 30, for example.
Well, yeah, and I mean in Ruby, it's so the answer was I'm paraphrasing. It's a construct that contains basically any number of values, and it can be one-dimensional in that it starts at 0 and it goes off to infinity, or it can be two-dimensional in that it's an array that contains other arrays. Ruby is no different. This is a slightly more sophisticated one. You know, I'm not going to dwell on this too much because you're going to be introduced as part of the coursework here. And we're already about 10 minutes over time. So really quick demonstration. It's funny that we did an array before we did that. Okay. I'd argue that this is the more primitive function, or sorry, the primitive data structure. Okay. Let's make an array. Now notice this this hashtag here, this pound sign. This means a comment in Ruby. So now anything that is behind the pound sign, the Ruby interpreter will ignore. You can put anything there. It won't get executed. And this is actually a really handy way of debugging. So watch what happens when I comment out hello Jeet. It's going to cause an error. It's going to say, you didn't define Jeet. Oh, what? I must not have saved. I didn't save. Ah, come on, come back. Where did that come from? There we go. Yeah, name error. Undefined local variable. So it printed out hello Chris. It printed out hello Dan. Couldn't print out hello Jeet because Jeet never got assigned. I put it behind a comment. Right? Very dramatic demonstration of what's happening here. So I'm going to put all these guys into an array, though. I'm going to say greetings. And an array begins with an open square bracket and closes with a closing square bracket. Now, again, it's like an if-else end. Make sure when you write the if, you put the end. Make sure that when you put the opening P tag, you define the closing P tag. Same thing with arrays, same thing with hashes. Inside this hash, I can put anything I want. And it just so happens I want to put in hello Chris. That's one value. I put in hello Dan. That's another value. I put in hello Jeet. That's another value. So now greetings contains all the values I just assigned. And if I put this out to screen, you're going to see what it looks like. It's actually not going to look too much different than what I have there. Oh, it actually prints it out quite nicely. Now, this is where arrays become valuable, very useful. I don't need to look at every single value in the array all the time. I can use what are called indexes. If I want to find this item, I use that same style of square bracket. Open with the square bracket, I close the square bracket, then I give it a numerical index. This is just an integer. It could be an integer stored in a variable, but it's going to be some value from negative infinity up to positive infinity, depending on the size of the array. So I just want to print out the very first greeting. When you're talking about Ruby, and this is actually common among many languages, you start counting at 0. Right? So I'm going to press enter. I'm going to save that, execute it, and this time I only get 1 because I indexed 1 value. If I want to get the next one, I give it the second index, which is 1. We started counting at 0. I want what's ever in slot 2. I get hello Dan. I get up to number 2, or sorry, value number 3, index 2, 0, 1, 2, hello Jeet. What happens if I go outside? What do you think is going to happen? Error message? Nah, just a nil. It's called nil. We went beyond the index of the array. And I can put any number in here at that point, and it's always going to return nil. And it's going to print this empty line to the screen because I guess that's what a nil looks like when it's printed to the screen. You can go up to like a million here. What happens if I do this? What do you think happens if I put a -1 in there? Any guesses? This is actually a really nice feature of Ruby. Press enter. Whoops. I must not have saved. Hang on. I didn't save. A little bit flaky with my saving today. Okay. Hello, Jeet. I started counting backwards. And if I do -2, same thing. This is going to be hello, Dan. It just starts counting backwards. So -3, of course, is going to give me hello, Chris. -4, out of bounds. Nil. Can't even see it. N-I-L. Nil. Okay. Array. Let's do a very quick hash value. Some languages call these dictionaries. And dictionaries are created with key value pairs. Now, if you imagine you're looking up a word in the dictionary, you say, I want to know the definition of, what's a funny word?
Sauerkraut.
Sauerkraut, sure. You would type in, or you would start, you'd flip open the book, you'd look at the S section, and then just because sauerkraut starts with an S, then what is it, A, and then U, and then I think that's how you spell sauerkraut. I'm not entirely sure, actually. But you look at it, you narrow it down, and you find the definition given that keyword, the keyword being sauerkraut. Now, of course, when you get in the dictionary and you finally find sauerkraut, there's a value associated with it, just kind of like when you're doing CSS. You've got a key, it's been assigned a value. In the case of a dictionary, sauerkraut or any given word might have multiple definitions, in which case it's kind of like an array. But let's make a very simple dictionary, and then you guys can do some work. Greetings. We'll call it a hash. Most people in Ruby call it a hash. So I say $. Now, unlike the array, hashes open and close with curly braces. Now, here's that key. A key is a symbol. We could say first greeting, and it's separated. So this is kind of looking like CSS here now. The key can either be a string or a symbol. In this case, it's going to be a symbol because there's no quotation marks around it. And I assign it a value. So the first one, I guess, was hello, Chris. And I'll just keep doing this. And you can put anything in here. It doesn't have to be any sort of specific type. The key value, that's the value on the left-hand side, either, as I said, has to be a string or a symbol. But the value side of it, that's to the right of the colon, can be any value, including another hash or another dictionary or another array or whatever you want. It could be another object. Doesn't matter. In fact, it will be an object because everything is an object in Ruby. So I'm going to say that. Now there's an opportunity for a syntax error here. Can anyone guess what it is? Not this. Anyone see any potential problems here? Let's try executing it. Oh, didn't execute. Did I save it? I did. Okay, it doesn't care. What I was chasing after is this. When you're defining key value pairs, you always separate the individual key value pairs with a comma. Again, kind of like CSS, except in CSS, you use a semicolon. That should have caused an error. I guess it doesn't, but I would have expected it to. Just make sure that you separate all these key value pairs with commas. Okay, so now this kind of starts looking a little bit like an array in that we can index it. But we don't use 0, 1, 2. We use the key, which is either a symbol or a string. So let's try put s greetings hash. I use the same square brackets as I do when I index, but I don't do this. I do this. I pass it the key value, or sorry, the key. I shouldn't say the key value because the key is assigned a value. So this time, put s greeting hash. Hello, Chris. I want to get the second one. I just pass it the second one. And now, just to close things off, There's, whoops, did I not save it again? Second reading. Oh, I did hello Chris twice. Look at that. So this should have been hello Dan, like that. Okay, problem solved. Now, I just want to show you the difference between the string and the symbol. String is fine. Symbol is fine. But they are not the same. So this is legitimate, but I can't use that colon prefix there, right? This denotes a symbol. I press enter. Did I not save it again? Oh, look at that. It just converted it to a symbol. This is not something I can take for granted. I use a framework, well, I use Sinatra day to day. This is a common problem. Okay, so I guess it does work. At least it does in ordinary vanilla Ruby. That's a bit of a shock. Hang on, let's try that. Just be sure. Let's try this as a string. Now, lo and behold, it might not work. Okay, here we go. That time it didn't work.
Doesn't like it as a string.
It doesn't like it as a string. Okay, well, yes.
I think the reason is you're using the documentation.
Oh.
It's still treats as.
Okay, so this would be the optional notation. Is this what you're getting at here? Okay, so like back in the olden days, this is how you used to assign key value pairs. We didn't have colons. We used what's called this rocket. Looks like a rocket ship. Okay, so let's try this. Thank you, Nick. Hello, Jeet. Now this time, isn't that funny? All right, so this time this shouldn't work, I think. Let's find out. Yeah, okay, that time it didn't work. Okay. Gave you a little bit too much information there, forgive me. Before I shut this down, quick recap. Ruby is object-oriented. Everything's an object. It was made by this guy. What a friendly looking guy. I just love him. He's fantastic. Different types of data types. Integers, floats, booleans, strings, very common, true of all languages. We assign some variables. We know that naming is very important. Give descriptive variable names, descriptive method names, whatever you're doing, make sure that you know what's contained in this variable or what this method is supposed to do. We combine strings using a technique called string interpolation. It opens up with a pound sign, has a curly brace, closes with a curly brace. One thing I forgot to mention is that when interpolating strings, you can only use double quotes. The single quotes won't work. It'll just print out the pound sign and the curly braces. Forgot to mention that. Didn't do a demo. Now you guys are totally sick of listening to me. We used if-else to control the flow. Is the number of planets 9? Is it 8? If it's anything different, then we don't know what solar system you're in. We defined a method. We didn't do anything quite this complex. We just took a value, we passed it to the method, we interpolated the string, and it says, hello, whoever. Hello, Dan, hello, Jeet, hello, Chris. We returned a response. We combined our data into a hash. This is the one you're going to see today, and this is kind of that introduction into a kind of a rough concept of how the database arranges your data. This is the introductory. It's not how it does it, but this is where you'll be starting off. And we created an array. So a lot of stuff, and we will do a more in-depth review because I guarantee looks easy. When you sit down and you do it, it's going to be a whole different ball game. So no questions? All right, get to work.